We're going to record. Perfect. Again, a huge thank you to James, and take it away, please, James.
Thanks very much, Laurie. As Laurie mentioned, my name is James Dyck. I'm the engineering specialist for crop systems and environment with OMAFRA. I'm based in the Niagara region in our Vineland regional office, and a big part of my job is to do this kind of thing to bring knowledge to farmers like yourselves. I certainly don't pretend to know everything there is to know about grain storage. I recognize that many of you on this call will have had a lot more experience than I have in terms of storing grain and running dryers, but I hope I can bring some new ideas, some things to think about, maybe some new things you hadn't realized that were coming up in research or things like that. So grain storage, grain handling is one of my areas of expertise, certainly from an engineering perspective, and so I hope I can bring some understanding for you today. Before we get started, I wanted to do a quick land acknowledgement. I recognize that many of us are in different parts of the province. I myself am located in the Niagara region, which is part of the Between the Lakes Treaty, Treaty 3, which was made in 1784 and updated in 1792 when they needed to clarify boundaries. I've read the treaty. It's about 2 pages long, and they bought that whole purple tract of land that you can see there for like around about $200,000 in today's money. So not a great deal of money for that amount of land, not a great deal of language in the treaty. And so I guess it's not really a surprise that there's a lot of contention around how things have been handled over the last couple hundred years. But I also wanted to recognize that prior to that, there were a couple of treaties in place amongst the Indigenous nations. One is, you may have heard of as the Dish with One Spoon treaty. This was an agreement between a number of nations in the area that basically signified that they recognized that the land was a communal resource, and the fact that there's one spoon means that kind of only one person can be taking a certain resource at a time, and they need to make sure that they're leaving enough for others. So it's really a cooperative, the idea of cooperation and sustainability. And then even before that, there was this treaty called the Two-Row Wampum, between Dutch settlers and the Indigenous nations. And the 2 purple rows that you see on this banner really recognize the fact that the nations had agreed to operate in parallel without disturbing each other. Kind of the metaphor is like 2 boats traveling down a river at the same time. So both headed in the same direction, but not disturbing each other. So I just wanted to recognize that and recognize amongst all these treaties, they do still continue to affect us today. There's a saying among the Indigenous people that I won't try to pronounce, but it's essentially, we are all treaty people. All these treaties continue to affect us today. So I just wanted to recognize that before we get started. So we are going to talk about grain drying and grain storage. I've kind of separated the first half of the presentation into grain drying, second half into storage. I recognize some of you may or may not have your own dryers, but as far as grain drying, we'll start by talking about the combine, because really that's where it starts. I'll get a bit into the physics of drying to help you understand how it works. Some things to think about, different types of dryers, how to help them be more efficient, how to manage quality, and then some alternatives. We're going to take a break in the middle, about 15 minutes. So that'll give you a chance to refresh your coffee, go to the washroom, that sort of thing. And then we'll move on to grain storage. So we'll talk about how to condition crops in the bin, aeration tips, how to manage moisture within your bin, even though the grain might seem to be dry, and some tools you can use, online tools that can be helpful. We'll finish off with a brief mention of safety and then some upcoming innovations that I like to keep my eye on. So without further ado, we'll get started and we'll talk about harvest. Now, I think it's important to recognize that, there's lots of things that can happen in your combine, but there is something that's pretty unpredictable that I think all of you probably have in your own combine, and that can be the driver. So I just want to mention that the driver has a big impact on the quality of harvest coming out of your combine. Now, a combine is a very complex piece of machinery. It's not called a combine for no reason. The name combine signifies that it's a combination of a threshing machine, a cutter, a residue management tool. All these things used to be done separately, and now it's all in this one machine. So we've got our header, and the header is where the crop starts to come into the machine. So you want to make sure that your header speed is set appropriately, that reel is or cutter bar is set to to a speed that's probably just a little bit faster than the crop coming in. So it's not pounding the daylights. You're not trying to thresh the grain in the header, just trying to guide it nicely into the machine. Once the grain enters the feeder house, you want to make sure that that feeder house is nice and smooth. There's no sharp edges. Again, you don't want to be threshing the grain out in the feeder house. So you want to make sure that chain speed is properly set. The thresher, this is where we want to beat the grain out of that shell, whether it's corn or wheat or soybeans. And a good thing to remember is that speed in your threshing system cracks it, but closeness is what actually threshes. So really what that means is you want to try and manage your combine to have the lowest speed that you can get away with, and a tighter concave, because that will maximize the threshing and minimize the damage. Once you get the grain to the cleaner and the sieves, you want to ramp up that airflow, because the airflow will help get the chaff out of there. But of course, watch your grain loss. So try and keep your airflow as high as you can while keeping the grain loss down. You can tighten the sieves up, but that will add re-threshing and additional risk of damage to your grain. So just keep that in mind. And then finally, the chaff spreader, you want to try and spread that chaff at full width if possible. It's not going to impact your harvest, but it will impact your crop planting next year, especially if you're in a no-till situation. So you really want to set that chaff spreader up to throw maximum width. And finally, I wanted to mention tires. If you've been to some of our OMAFRA events in the last few years, we've talked a lot about tires and compaction. And I want to recognize that many combines today, especially large ones, are running duals. That can be a good option to minimize your compaction, but actually large VF, which is very flexible, the large single tires can be just as good or even better than duals, because they can float really well. They can have a really nice big footprint. So you don't have to go to duals, and you do want to keep in mind the tires on the back of your combine are important too, because those tires carry a lot of weight. And while I'm talking about tires, I want to ask if your combine's set up for the right ground speed. You know, are you driving a machine like this in the field and trying to get the best quality crop off, or are you trying to do it as quickly as possible? Are you, trying to pull something out of NASCAR? Well, there's a lot of considerations when you're driving in a field. First of all, the crop conditions. We all know that sometimes you can drive faster, sometimes you can't. The field conditions, is it wet? Is it carrying well? How is the combine handling the load? What's your header width? And even what's the operator experience? Are you as comfortable driving at a certain speed as your younger son or your grandson or your nephew or whoever else might be running the machine? So that's important too. And you want to make sure that however you're planning to drive, you want to set your combine up for that, set your speeds up for that, so that at the speed you're driving, the combine is going to be fully loaded, because that will help your combine get the best quality out. If you are going to make adjustments, and you should be, because you're going to want to adjust it on the fly. The combine isn't something you set on day one of harvest and never touch it again. You're probably going to continuously be adjusting cylinder speeds, adjusting various things as your harvest goes. You want to make one adjustment at a time, because if you try and adjust everything at once and something goes wrong, you're not going to know which adjustment was it that put things out. So make one change, see how that affects your grain sample, then make another change. You do want to maintain your engine speed, keep it right up there, because that helps your combine run efficiently. And again, keeping the machine fully loaded. So, don't run it half empty if you can. Obviously, sometimes you've got areas of your fields that don't have as much crop, but you do want to try and keep that machine fully loaded. So that'll keep the thresher fully loaded, keep the damage down, and help it do its best job threshing. You've probably seen this sign on the roads as you're driving in the winter. Well, keep this in mind when you're combining as well. The same principles apply. You want to drive according to the field conditions, the crop conditions. That's going to get the best out of your machine. And sometimes you can't get a fantastic sample. Sometimes it's about getting the best sample you can, given the conditions. We've all harvested in less than optimal conditions, and sometimes that's just what you have to do. But your combine's a powerful machine, and if you can do a good job of getting a quality grain sample, that'll take you a long way to storing that sample well as you put it into your bins. So let's talk about drying. And I'm going to dive a little bit into physics right now. So I hope that's okay, but this is kind of the background of how grain drying works, especially for those of you that are drying grain in your bins. I know I heard some of that on the intro before we started this presentation. Psychrometrics is a term from physics, and it means basically the properties of the air around us. And air has a lot to do with the, well, air is what dries our grain. So the moisture, the temperature, and what you're seeing on the slide right now is a so-called a psychrometric chart. And what this chart will tell you is if you pick a point on this chart, it will tell you everything about the air represented by that point. So if you know two properties of air, like the temperature and the relative humidity, you can use a chart like this to find out every other property of the air. So I'm going to simplify it a bit, and we're going to pick a point right here in the center. So the bottom of this chart is temperature, and this point that I've picked is about 21 degrees Celsius. These curving lines are relative humidity. So this curving line here, the point I picked is 50%. Those are most of the numbers that we know when we talk about air and weather. Temperature, relative humidity. There's lots of other factors for air that come into play when grain drying though. Dew point temperature, probably we know about that. You just go horizontally on this chart, and at these conditions, it's about 9.9 degrees. Absolute humidity is the actual quantity of water in the air. So at 21 degrees and 50% relative humidity, if I've got a kilogram of air, that kilogram has about 8 grams of water in it. And so if I heat up that air, that 8 grams is going to stay there. Then we've got wet bulb temperature, which is a different way of measuring humidity. Basically, you get a wet sock, you put it over your thermometer, and that evaporative cooling is going to tell you what the wet bulb temperature is. So you can use that to find pretty accurately what your humidity is. There's also enthalpy, which is the energy in the air. And finally, the specific volume or the opposite of density. So air density changes at different temperatures, and that's what specific volume is telling us. So all of this information we can get if we just know two properties of air. The other thing we can use a psychrometric chart for is seeing what's going to happen when we change properties. And in grain drying, this is important when we heat air up. So if you heat air up, you're going to move to the right on the chart. If you cool it down, move to the left. You add humidity, you go up. If you take humidity out without changing the temperature, you go down. If you're heating and humidifying, you're going up and to the right, cooling and dehumidifying down and to the left. And that's really what our air conditioning in our homes does for us. Evaporative cooling is where you take, you're relying on water to cool down. So some of you with livestock barns may be doing that. If you've got misters in your barn, that's a form of evaporative cooling. And then desiccant dehumidifying is where you've got actually a material that's absorbing water rather than refrigerant, which is what an air conditioner uses. So a grain dryer, what we're trying to do is heat air up, and thereby we're reducing our relative humidity. We're not changing the absolute humidity, but as we move to the right on the chart, you can see that that the amount of water that air can hold goes up a lot, and I'll show you that again in a slide in a minute. And then natural air grain drying, actually evaporative cooling is really important. But let's talk about why humidity is so important in grain drying. So if we start with air, air can hold a certain amount of water. We know that, that's relative humidity. We just talked about that. So if we've got air, let's say it's 0 degrees, and our air at 0 degrees can hold, let's say, a quantity of 1 for water. So if it's 100% humidity, that means that air is fully saturated, can't hold any more water. If we heat that air up, and we do that without adding any water, we've increased the amount of water that our air can hold. So we've increased the size of our cup. But if we haven't added any water, then now we're at roughly 50% humidity if we go from 0 to 10 degrees. And then if we do that again to 20 degrees, we've increased again the quantity of water our air can hold, but now we're at 25% relative humidity. And so air at 0 degrees and 100% humidity, that's not good for drying grain, right? It can't absorb any more water. In fact, if we blow that kind of air through our grain, that grain is going to absorb moisture from the air. The grain's going to get wetter. But we can heat that air up and dry it out, and then that air is useful for drying. And in a high temperature dryer, you're heating that air so high that the relative humidity becomes essentially 0. And so then it'll dry the grain very quickly, and we're actually removing the grain from the dryer before it gets to fully dry as far as the air goes. And all of this, I know this is a lot of physics, a lot of details. I wanted you to understand the background, but you don't need to remember it, because you can just look at a chart like this, which is called the Equilibrium Moisture Content Chart, or EMC chart. And what this chart tells you is, based on the temperature and humidity of your air, what moisture level is your grain eventually going to reach. So for example, the room I'm sitting in right now is about 20 degrees Celsius. It's probably about 50% humidity, probably very similar to the rooms you're sitting in. So if I look up 20 degrees on the left-hand side of the chart, 50% humidity on the top. Now this chart's for corn. So that means if I had a pile of corn in this room, doesn't matter what moisture that corn is at, eventually that corn is going to reach about 11.5% moisture, because that corn is going to give off its moisture into the air and or absorb moisture from the air until it's equalized. And the reason this works is even a pile of corn or a bin full of corn is still about 40% airspace. So there's lots of room for air to move in that grain. Simon, you were talking about the ag bags and getting air in there with high moisture corn. Yeah, there's still a lot of air pockets in there, even if it's quote unquote full of corn. So air will quickly fill up those spaces. And so what this chart means is that if you can dry grain just using natural air, as long as you watch the temperature and the humidity, eventually your grain is going to reach these levels. So those of you drying grain just in a bin, these kind of charts I don't have in the slides here. I don't have a chart for soybeans or wheat, but they're readily available online. I can make sure they get sent out afterwards so that you have them as a resource, and you can use that and watch the weather to plan whether or not it's a good idea to be drying your grain. So that's kind of the background of how grain drying works. And I'm going to talk now about some different types of dryers. Now, many of you probably recognize some of these. Maybe you have them on your farms. These are many of the most common types of grain dryers in use today. First of all, we've got fans. You just got a fan on your bin with no heat. I know some of you talked about that already. You might have a heated dryer where you've got a fan plus a heater bolted to your bin. You might have a small portable batch dryer, or a larger one that's not portable, it's just in a bin. Could have a top dry system, whether it's auto flow or batch type. And then you get into the big continuous flow dryers, whether it's a stackable upright, whether it's mixed flow, or even a large tower. Obviously, the bigger dryers tend to be used more at elevators, and the smaller dryers tend to be used on farm. But a couple of years ago, we at OMAFRA, in conjunction with University of Guelph, actually did a survey of Ontario grain dryer operators to find out what are people actually using in Ontario today as far as grain dryers go. So I'm just going to show you the results from that chart, that survey, because I think they're pretty interesting. What we found amongst the different dryer types, first of all, we had about 32 elevators respond and about 29 farmers. So obviously a small sample compared to the number of elevators and number of farmers in Ontario. But I think it's really interesting what we found. So first of all, no surprise really, the smaller dryers like bin dryers, batch dryers tend to be used more on farm. The larger tower and continuous flow dryers tend to be used more on elevators. But the continuous flow dryer, the stackable type, is the most popular both on farms and in grain elevators. I think that speaks to its versatility, the range of sizes available, and the ease of use. So lots of people using that type of dryer. Now, when we asked in the survey about drying capacity, and this might be interesting for those of you that are thinking about putting up a larger dryer, or wondering how big a dryer you might need, we asked farmers and elevators, how much grain are they drying every year in bushels, and what's their drying capacity in bushels per hour? And then we plotted that on a chart. Now, these are self-reported numbers, so take them with a grain of salt, because as we know, people don't always report everything exactly. They might have estimated, say, 50,000 bushels when they actually dried 60,000 or 48. So take it with a grain of salt. But what you see here is kind of where things land. So on the left-hand side, we've got total bushels dried per year, and on the right-hand side, we've got drying capacity. Now, the blue is elevators, the orange down here in this small area is the farms. So let's zoom in on that area so you can see the farms a bit more. But I think what's most interesting is the trend. And the trend showed us that about for every 100,000 bushels of grain that was being dried, whether on farm or in elevators, on a farm, the average farm had a dryer that was about 500 bushels per hour of capacity. The average elevator had a dryer that was only about 240 bushels per hour. So what that means is that an elevator is using their dryer a lot more to dry the same amount of grain. They're using their dryer for longer. They're using their dryer to dry more grain for the same capacity. Not really a surprise. Elevators, we'd expect them to be drying more grain than the average farm. But if you are a farmer and you're thinking about putting up a grain dryer, you're not sure how big you might need to have your dryer, think in this range, 500 bushels per hour for every roughly 100,000 bushels you expect to be drying per year is a good place to start. And then you can talk with your grain dryer supplier to see if that makes sense, what the options are at that size range. I thought it was a really interesting trend point that we were able to find from this survey. Did want to touch too on energy use of different dryer types. Energy obviously is a big cost for grain drying, and I'm going to talk more about that in a slide or two. But the different dryer types that we've talked about, they do use energy differently. And what you're seeing on this chart, I basically compiled what I could find from a number of different studies that looked at the grain dryer energy use. Now, these were done in different places, different years, so they're not necessarily all completely comparable. But what the chart kind of shows you is the range is the gray bars, and then the black dot is sort of where the average was, or the more common values in terms of the studies that I found. So the takeaway from this chart is that yes, there are big differences. There can be big differences in how dryers use energy, but they all tend to fall in the same overall range. So any dryer can be operated efficiently and really well, and any dryer can be operated poorly and inefficiently. So it's about how well do you maintain your dryer? How well do you keep those screens clean? How clean is the grain sample going in? What are your weather conditions? What's the quality of your grain? All of these things impact the drying, and you can't always control them. So as long as you're doing what you can to maintain the dryer that you have well, keep it optimized, keep it clean, make sure that the fans are running properly, that it's not wasting energy, that you're not losing heat somewhere. Really, you're doing the best that you can. If you are in the market for a new dryer, you can ask the questions of the dryer supplier. Say, how much energy does this dryer use compared to other ones? And they can give you an idea. And I'll talk more about those numbers in a minute. But you can see there's some numbers on the slide here, and I'll show you how you can figure out what your own dryer does. I see there's a question in the chat. What is Dorsers? Dorsers is a type of tower dryer. It was built, is still built in Ontario. It's owned by Millennium Dryers now. It's a big rectangular dryer, so a tower tends to be circular. Dorsers were rectangular. They were enclosed. They operated a little bit differently. They had integrated heat recovery, so they tended to be pretty efficient. They were developed here in Ontario, and you can still buy them today. But some of the big elevators do still operate Dorsers, and I found a few studies that showed them individually. So by and large, they align with the tower dryers. They tend to be a little more efficient. So if you're looking for a bigger tower dryer, could be something to look at. But for most, for smaller farmers, like I was hearing on the call, I think a lot of the people on the call today are maybe smaller scale farmers. You're probably tending toward some of the bin dryers or batch dryers.
James,
Let's
can I
talk.
throw in a question?
Yeah, sure.
Just curious, stirrators looks like they're fairly inefficient. Why would that be?
So that's a great question. Nathan, I think it was.
Yep.
Yeah. It was partly the studies that I found. So I don't know, can't tell you off the top of my head why the stirrator was so inefficient up at the top. Stirrators, one of the differences with stirrators, as many of you might know, most batch dryers tend to dry from the bottom up. So the grain at the top of your bin, you got a bin full of grain. The grain at the top isn't going to be dry until all the grain below it is dry. Whereas in a stirrator, you are actively mixing that grain. So the entire grain mass kind of dries all at once. And it comes back a bit to the humidity discussion. So as dry air goes up through your grain and it absorbs moisture, that air gets wetter, and eventually that air gets to basically 100% humidity. And at that point, it's not drying anymore. Even if there's grain to go through, it'll just kind of exhaust out of the bin without doing any more drying. In a stirrator, as that whole grain mass comes down, once that at the beginning, it's fine because the grain's really wet. It's going to soak up all the moisture from that grain. But as the grain gets down lower, maybe if I jump back to, just give me 1 sec here. I'm trying to see if I can make some sense of this for you. I'm going to jump back a slide or two to this one. And so if, as your grain is drying down, let's say your grain is now at 16% humidity. Well, your air coming out of that bin is probably only at, if it's your grain's at 16 or 17%, it's not dry enough yet, but the air coming out of that bin is only at 80% humidity, perhaps. So you haven't maximized the drying potential of that air. As the grain gets drier, you've still got, like, if you had wetter grain above it, that wetter grain would actually absorb more moisture, or that air would absorb more moisture from that wetter grain. So because the whole grain mass is at the same moisture, it can take a little bit more energy. Not sure if I'm explaining it super well, but it's you do have the same problem in a tower dryer as it gets lower in a tower dryer. So right at the top of a tower, the air coming out is basically fully saturated. But as you get lower down, the air coming out is hotter and it's drier, because as that grain gets drier, there's less moisture to evaporate. That's why you often see on a tower dryer, you'll see a plenum around it, kind of on the bottom third, and you're recapturing some of that heat because that air hasn't fully used all its drying potential. You can recirculate that heat back into the drying fan and recapture some energy. So in a stirrator, you can have the same thing happen, whereas once that grain gets close to dry, not quite dry, but you're no longer maximizing the potential of the air going through it to soak up moisture. So you are wasting some heat. That's partly why. We can talk more about that. If you've got more questions, feel free to follow up with me afterwards. My number is at the end of this presentation, and I'd be happy to chat more. I do want to keep going, but please feel free to jump in if you do have more questions. So I'm gonna talk.
Sorry, James. On the stirrator, we built our first full floor bin in 1991, and the question was asked, "Do you want a stirrator in it?" And we decided not to. There were some, and there's Derek Industrious cold floor, but what seemed to happen with stirrators, your fines end up on the bottom, and it restricts the airflow. That's what I have learned. So not to say that is always right, but that was a problem.
Yeah, I could see that happening too, Simon. That's a good point. Because as you're moving that grain, the fines are going to sort of sift their way down and make their way down to the bottom of the grain mass because you're constantly moving it. Whereas if that grain mass was stationary, the fines would kind of stay put.
Yeah.
So just like if you're sifting flour in your kitchen, eventually, it all falls to the bottom, and the same thing would happen in a stirrator bin. There's also more moving parts in a stirrator bin, so your augers break. They do use a little bit of power too. You probably want to avoid a stirrator if you're growing IP soybeans, because if you mix up those beans, it's an oil seed, they'll turn almost a gray color, and that's not usually desirable from an IP standpoint. Regular crush beans is fine, but that's something else to be cautious of. If you do have a stirrator, you're drying soybeans, maybe turn the stirrator off for the soybeans. As we all know, grain drying is expensive. Our cost of production documents from this year, 2023, show that grain drying alone costs about 13% of the cost of drying corn, or cost of growing corn, for 8 points of removal, which is the number we use in our cost of production, it's about $24 a ton. It's the third largest component of growing corn aside from seed and fertilizer. And actually, it used to be a bit of a larger percentage. The problem is in the last couple of years, fertility has gone up a lot in cost, as we all know. But grain drying is still the third largest component, and it uses a lot of energy. Whether you're drying it yourself or whether you're having somebody else dry it, there is a significant cost here. So I wanted to talk briefly about how to reduce energy use in a grain dryer if you have your own system. If you don't have your own system, this may not be as applicable for you, but I think it's still good to be aware of, because this principle that I'm about to talk about applies to energy use across your farm or in your own house. So it's good to know as well. And I'm going to show you the process to go through when you're thinking about reducing energy use somewhere. First, it starts by knowing how much energy you're using right now. You probably know how much you're paying because you're paying your fuel bills, but it's also important to look at the energy number, not just the dollar number, because as we know, fuel prices go up. Usually they don't go down, but that doesn't mean you're using more energy than you did last year. It just means you're paying more. So you do need to watch the actual energy number as well. Once you've kept track of that, then you can look at, am I wasting energy somewhere? Do I have something turned on that doesn't need to be turned on? Am I running my aeration fans too long? Is my elevator leg running empty? Those sorts of things. Are there ways that you can reduce your energy use just by simply reducing the amount of power that you're wasting? Then you look at energy efficiency, and this is where you might have to spend a bit of money to add some upgrades or change something, add some new controls. It's going to help you run things a bit more efficiently. Demand management, I'm just going to touch on it. This is talking more about reducing your overall electricity draw. This is more of an issue for large farms that are running on a demand service for their hydro. Most of you on this call probably are not, but I'll touch on it anyway. And then finally, if you are looking at an alternative fuel of some kind, whether it's biomass, whether it's some other power source or an alternative fuel, you want to probably look at that last, because if you do that first, you might be wasting energy somewhere. You'll need a bigger alternative system than you would if you do all the efficiency stuff first. So when you're looking at your own property, this is where I would suggest starting. If we're talking about grain drying, you want to know a few numbers. First of all, as I mentioned, you want to know how much fuel are you actually using, and you can get that from your fuel bills or your fuel meter, not just the dollar value, but the actual quantity of fuel, whether it's liters of propane or cubic meters of natural gas, or a different fuel, liters of diesel, perhaps. Whatever fuel you're using, find out the actual quantity that you've used over the course of time, ideally the course of the entirety of your drying season. Then you want to know from your drying records, how many bushels of grain did you actually dry over the course of time it took you to use whatever amount of fuel it did. So you need those numbers, the amount of fuel you used and the amount of grain you dried over that same amount of time. And that'll get you the fuel you used per bushel, which is a good number. But let's take it even a little bit further. The next number is really easy. You just pick one of two, depending which fuel you're using, and this represents the quantity of actual energy in that cubic meter of gas or in that liter of propane. And finally, you want to know, what was the moisture of the grain? How much water did you actually remove from that grain? And you can figure that out by looking at a chart like this. You start with the moisture level you had coming in on the side. Let's say your corn was at 24% this year. So you look that up in the blue area. And if you dried that corn down to 15%, that means you removed, for every bushel of grain you dried, you removed about 6.5 pounds of water from that bushel of grain. So you plug those numbers into your chart, and what you get for your grain dryer is a number that's probably somewhere between 2,000 and 3,000 BTUs per pound. This is the amount of actual energy that it takes you to evaporate 1 pound of water from your grain over the course of your drying season. It sounds like a bit of an obscure number, but the reason you want to know this number is then when you go talk to, say, your dryer supplier, or somebody else, you're talking at a farm show and you're wondering how efficient somebody's equipment is, they can usually give you this number. And it might not be exactly compared to your own drying conditions, but it'll give you an idea at least of the performance of different dryer types. And if you look at different research studies, this is often the number they use to compare dryer energy use. So this is how you can figure it out for your own dryer. And if you haven't, I would certainly suggest, pardon me, I would suggest starting to keep track of the fuel use of your dryer in a drying season and how many and how many bushels you're drying and the moisture level. So you can do this kind of high level number. Otherwise, if you don't track this kind of thing, you don't even really know whether or not your dryer is doing a good job from an energy perspective. And then you hear stories about, well, you should get this control system, or you should make this change to make your dryer more efficient. But if you don't know how efficient your dryer is to begin with, it's hard to know if those kind of changes are going to make a difference. You can also hire somebody to do a more detailed energy audit of your farm, not only the grain dryer, but other components as well. This can be everything from somebody who's walking through your farm and kind of pointing out areas where you can improve things, to actually installing detailed metering equipment on various loads. Now, for smaller farms, probably that cost might be a little more than you need to bear, but for larger facilities, it can make a big difference, because it can help them see where their biggest energy users are and help them find things that they can do about it. There's always steps you can take to reduce or manage your energy use. You can put in place, even just putting in place permanent monitoring can help you see when things are running and when they're not. You might not realize that somebody left an auger running or a fan running that didn't need to be running, and having monitoring can show you that. If you've got large motors like dryer motors, elevator motors, big augers, it is a good idea to put an amp meter on those, because that can show you if something is starting to draw more current than it normally does. That might mean that something is wearing out, or that that there's a bearing that's off, or that the load is wrong. So that can tell you something needs to be serviced. You can even use an infrared camera, and some of your insurance companies might be able to lend you one to inspect your electrical panels, your electrical connections, just looking for hot spots that might indicate something's coming loose or wearing out. There's other things you can do. You can put in more efficient motors. You can put in variable speed drives on your motors. You can put in sensors in your bin that can help you control your fans to the moisture level of the grain. So there's lots you can do. And some of these things can help certainly manage your energy use as well. From a fuel perspective, one of the most important things you can do is have your grain dryer burner optimized. There's a study done in Alberta over the last couple of years that found a well-optimized burner, meaning the air to fuel mixture for that burner is dialed in properly, you can save up to 12% in fuel use. So the reason that's important is that obviously if you don't have enough air in your burner, you're going to be not burning all your fuel, and so that you're wasting fuel. If you've got too much air in there, though, you're actually cooling that flame down, and you're not getting out all the heat that you could have. So there is a fine balance there to have just enough air to burn all the fuel without too much that you're cooling it down. And a good gas tech can help you balance your burner in such a way that you're maximizing that efficiency. So I think that's money that's worthwhile spending if you do have a gas dryer. Once every few years or once a year, depending how much you use it, have a gas tech come in and make sure that your burner is optimized. You can actually increase your drying temperature, and I'll talk about that on the next slide. You can do things like insulate your dryer. If you've got a top dry with exposed surfaces, you can insulate that. And we worked with a farmer to do that, and we estimated, depending on how much he's using his dryer, different fuels, things like that, could save between $1,000 and $4,000 a month during the time he is operating that dryer by insulating. So there can be some dollar savings there. And then, as I mentioned, some of the large dryers, they can have heat exchangers on the lower part of the plenum to recapture some of that wasted heat that hasn't fully been utilized, rather than dumping it into the atmosphere and heating up a whole new bunch of air. You put that back in the burner, heat it up again, and you're gaining some efficiency there. Let's talk briefly about increasing your dryer temperature. Now, this is something you should do very carefully because it can affect your grain quality. And I'll talk about that in a little bit, but increasing your air temperature can actually improve your efficiency. Now, it sounds counterintuitive because yes, increasing your temperature is going to use more fuel, but it will also, as I showed you earlier, increase the amount of water that air can hold. And the amount of water capacity increases a lot faster than the amount of heat that it takes. So heat increases linearly. If I'm doubling the temperature of my air, it's going to double the amount of heat that I'm using, but it's going to like quadruple the amount of water that air can hold. So you can dial up your temperature and dry that grain a bit faster and more efficiently. If you're going to do this, I would highly suggest doing it in stages. Do it in steps of about, say, 5 degrees Celsius or 10 degrees Fahrenheit. Turn up your dryer and let it stabilize. Dry a full batch or a cycle and watch the grain quality coming out. Inspect it really closely. Is the test weight okay? Is there more cracking? All of those things. If the grain quality is okay, then you probably are okay, and you might even be able to increase that temperature a little bit more and get a bit more efficiency. If it's not okay, if you're seeing deterioration in quality, you probably want to dial that temperature back. You can also consider generating electricity. This might be more relevant for large farms that are dealing with demand. Really, the main question here is, can you generate it cheaper than what you can buy from the utility? So I can't necessarily answer that question for you. This is a great place to have a consultant involved because there's a lot of factors that go into a generator. If you are considering a generator, you can get some more efficiency out of it by recapturing some of the heat off that generator as well. It's called combined heat and power, or CHP. Not only are you getting the electricity, but you're sticking a radiator in front of your grain dryer and using that heat. Or maybe you've got a livestock barn that you can put some of that heat into. So if you're thinking about a generator, try and recapture some of the heat as well. You can also look at different fuel sources. Obviously, propane is going to be a big one that many of you on this call are using, or perhaps you're on a natural gas pipeline. Both of these, the infrastructure is easy. It's there. You just have to hook up to a pipe or a tank. It's really simple. You get a bill at the end of the month. The problem is that bill includes carbon tax, and that carbon tax does keep increasing. So it does mean that aside from fuel price variability, our fuels will continue to get a bit more expensive from that perspective. Not sure if any of you on this call are members of the Innovative Farmers Association. They just completed a feasibility study looking at hydrogen, as well as a couple of other things, but mainly hydrogen. What they found was that, first of all, the infrastructure is just not there right now. To put infrastructure on your own farm to store hydrogen is quite expensive. It's relatively simple, like it's still a gaseous fuel that goes into a burner, but having the infrastructure and having to do that is going to be pretty costly. There is no carbon tax though on hydrogen. So it's probably a few years out before this is really practical for grain drying. It is starting to be used as a transportation fuel in some larger centers. So you might see more about that in the coming years, but it'll be something to watch. Another option could be electricity. Probably not just straight up electric heater, because that's going to be a lot of money to operate. But if you're using electricity from a heat pump, which is essentially an air conditioner running in reverse, it's actually roughly as cost effective operationally as natural gas, which might sound pretty surprising. The problem is that it's a more complicated system. So it's going to cost you some money to install it. And from that perspective, it's probably not the simplest option. You have to manage refrigerant as well. It's best for lower temperature drying, so it's not great for super high temperature, and it's probably not practical for large commercial dryers, but for on-farm systems, especially smaller ones, specialty crops, lower temperature drying, it can be a really good fit. And actually, Grain Farmers of Ontario is funding a research project right now that's looking at scaling up heat pump drying in Ontario. So it'll be, I'm involved in that project, and I'm keeping a close eye on it to see how things evolve over the next couple of years. The last thing you could consider is biomass, meaning wood chips or wood pellets. Now, we've been burning with wood for centuries. It's a great heat source. The infrastructure, you can buy it. You can buy wood pellets. They're available commercially. You do have to have infrastructure on your own farm to manage. It's a solid fuel, so you've got to have bins and conveyors to feed it into your drying equipment. But you can buy drying equipment these days that is set up for wood-fired drying. The other advantage of wood, obviously, is that it grows on trees. So it's readily available around us. And all joking aside, there are a lot of ways of sourcing sustainably managed wood products these days. So to find sustainable fuel sources from that perspective, I think we'll see an increase in wood-fired grain drying over the next few years. That's kind of my expectation. But we'll see where the industry goes with that. From a cost perspective, wanted to touch briefly on that. So this is out of the Innovative Farmers study, and And just what you see basically is that hydrogen is way more expensive for the same quantity of energy than anything else. Natural gas is far and away the cheapest, although biomass is very cost competitive as well. Now, if we look forward to 2030, we're expecting that natural gas and propane are both going to increase quite a bit. Hydrogen is probably going to be cheaper just because the infrastructure is going to be a bit closer to being ready. Electricity and biomass, there could be some fluctuation in those pricings, but we expect that biomass is probably going to remain pretty competitive, especially when carbon tax is figured in. So even if there's a big range in biomass pricing, it may still be a viable fuel for grain drying. So something to keep an eye on. And as I mentioned, Grain Farmers of Ontario has a couple of projects they're funding right now. One is looking at burning bales actually and doing a hybrid grain drying system with propane. And the other one is looking at heat pumps. So hopefully in a couple of years, there'll be some results that we can talk about with those, but I'm very interested to see how these things shake out. Wanted to touch a little bit on quality now, grain quality. I mentioned this earlier when we were talking about grain temperature. First of all, let's talk about the combine. So I did a trial back in 2017, worked with a farmer to look at grain damage in the combine and after drying. And what we found, we kind of broke things into 3 categories. So major damage is where, that's the orange, that's where you've got kernels that are split in half or shattered. Minor damage is where you've got mostly whole kernels, but they're cracked or they're damaging. So, at risk of more damage as they go through grain elevators and things like that. And then your screenings, which is your fines. So what we found was that as moisture got higher in the field, actually the fines and the major damage stayed roughly the same, but the minor damage actually went up. Now we were dealing with high moisture corn, period. Like our lowest sample was about 27%. So I don't know how this would pan out kind of at a lower moisture, kind of low 20s, but it did seem that the minor damage went up as the moisture went up. And I wonder if that's because the kernel just got so soft that it was more easily damaged as it went through the combine. Also, as the test weight went down, grain damage went up as well. So not really a surprise there, because a higher test weight means that your kernel is going to be more dense. So it's probably a little more resilient to all the bashing around that happens in a combine. A looser kernel, a slightly less dense kernel, is probably more likely to get cracked and fractured. So we did see that shake out in this research. Once that grain goes through the dryer, what we found is that kind of before and after the dryer, there was a big change in grain damage. So if we had 0.4% fines before the dryer, we had almost 2% after the dryer. Still a manageable level of fines from a grain quality standpoint, but it was a big increase in the dryer, almost 5 times. There wasn't a big change in major damage, actually a slight decrease, and perhaps that was some of the big kernels just turning, or the damaged kernels just turning into fines. Maybe that represented some of the fines increase. But we did see a lot of increase in minor damage. So this is the stress cracking kernels that appeared to be whole, but that you look upon closer inspection were damaged. So I mean, these wouldn't come out in a quality check at the elevator, but over longer storage, or the more you move them in an elevator or in an auger, it could result in more fines and more damage over time. When we look at test weight in the dryer, most of us know that test weight increases in a grain dryer, and that's because as you evaporate water from the kernels, those kernels do get more dense. The grain mass left behind is denser than the water. So the kernels shrink, we know that, and you get a higher test weight. What you might not realize is that the moisture level actually affects test weight quite a bit. Or rather, what I mean is the temperature that we dry grain at affects the final test weight of grain that we're drying. And part of the reason for this, I think, is that when we dry grain at a really high temperature, we're drying it very quickly. And so then that grain, there's a big differential, because obviously grain dries from the outside in. So the outside of that kernel is dry, the inside gets hot and wet, and it starts to swell. And so as the grain is dried very quickly, that kernel can swell a lot because there's a big moisture differential. Dry that grain slowly, there's that moisture inside has a chance to migrate to the outside. So it's a much more even moisture break down within the kernel itself. And as a result, you don't get as much swelling. And so grain dried at a lower temperature, you'll actually get a much bigger test weight increase. So this is helpful if you've got grain that's kind of marginal quality. If you dry it at a lower temperature, you can get a bit more test weight gain out of it. And it results in perhaps a better grain sample. Conversely, if you've got good quality grain and you dry it at a higher temperature, you might not get as much test weight gain, but if you're already in grade 2, it probably doesn't really matter very much. Now, if you are looking to try and manage the quality in your dryer, it's kind of the opposite of increasing your temperature. You want to be decreasing your drying temperature in stages of about 5 degrees. Let it equalize, measure your test weight. And if you're seeing a continual increase in your test weight, like incremental as you go down, you could probably reduce your temperature even more, get even more test weight gain. Once the test weight's stabilized, you can probably ramp up your temperature a little bit to speed it up. But there is a balance point between test weight gain and efficiency. So if test weight's more important to you, dry at a lower temperature. If efficiency is more important to you, dry at a higher temperature. That's kind of the message here. There is a bit of a trade-off. Before we get to a break, I wanted to talk about ambient drying, because some of you mentioned that you were just doing bin drying. So I've talked a lot about heated air drying, but you can certainly dry grain without adding any heat at all. What you're seeing on this chart is a few locations in Ontario. The top line is temperature and the bottom line is humidity. And if you think back to our equilibrium moisture chart, if you remember, there's kind of the 60 to 70% humidity range is almost across all of the temperature bands. That'll get you pretty close to where you want to be in terms of drying your grain, in terms of moisture level. And what you find when you look at our average weather conditions in Ontario is that between March to kind of early September, mid-September, even into October, we have average humidities that are in that 60% range. Typically in the winter, we get a bit more humid. So late season, it can be tough to dry grain that's in air that's really humid. But you can actually add a little bit of heat to your grain or to your air, as I showed you earlier in that chart. If you heat up the air just a little bit, you'll reduce that humidity. You're not trying to heat it up so much because what we're working on is this equilibrium drying principle. So you're trying to get the air just to that point where over time, you're not going to over dry that grain. You'll get it right to where you want it in that, say, 15% range for corn, maybe 13% for beans. So in the summertime, in most parts of Ontario, you can do that really easily in a bin. Later in the fall, you might need to add a bit of extra heat to do it. But if you are going to dry grain with natural air, it's important to set your bin up well. First of all, you probably don't want to start with much more than about 18 to 20% moisture. With corn, maybe you can get away with a little more than that. Part of the problem is you're just not going to be able to dry it fast enough before it spoils. We'll talk about that after the break. You also want a bin with a sizable fan. Your average aeration fan isn't going to be big enough just because it's going to take too long. So you do want a fan that can run at least 1 to 2 CFM per bushel. And most of this we'll talk about after the break as well, if you're not sure exactly what that kind of measurement means. You want to have a good number of bin vents, basically a certain number of square footage for every 1,000 CFM. Don't fill your bin too full. Again, it's just going to take too long and you'll be choking off your airflow. And you definitely want to make sure that you're leveling that bin, you're coring out all those fines. If you don't level the bin, it's going to take you potentially a lot longer to dry that grain. If full natural air drying seems a little too complicated, you can do a hybrid system. If you've got a high temperature dryer, one option is just not cool the grain in the dryer, but put the grain into a bin after the dryer and cool it down there slowly. That lets your dryer continue to dry wet grain, and it lets your cooling grain take advantage of the residual heat that's left over after the dryer. If you cool that grain too much, all that heat's just going to disappear and it's not going to dry up any more moisture. But if you let that grain sit for a few hours, you cool it down slowly over the course of a day, that residual heat is actually going to drive a lot more moisture out of that grain. You can get an extra 1 or 2 points out of that grain. It means it can come out of the dryer at 17, cool it in your bin, and you'll still get it down to 15%. You can gain 10 to 30% in energy savings, potentially a bit of cost savings, although you will be running some fans for longer. So there is bit of an electricity penalty. And it does require you to have kind of a dedicated cooling bin. But if you have the infrastructure for it, this can be a good way to get more capacity out of your dryer without actually buying a new dryer. You can also try and avoid drying altogether. We've talked about high moisture storage before the session begins. If you've got livestock, this can be a good option. Who says you have to dry to 15 if your livestock are perfectly happy eating it at 20? As long as you can store it in a way that it's going to be oxygen limited. So whether that's in an ag bag, you seal it up, and then once you open it, you use it quickly, or you grind it up, or have some other storage method like a bunker silo. But that can reduce your demand for drying, and it does tend to preserve most of the nutrition in that grain. You can also look at growing shorter season corn. Might sound a little bit odd, but if you take a look at the last few years of data from the Ontario Corn Committee trials, they keep track of moisture levels and yields. And so what I've done is taken kind of that, and I see my y-axis on the chart is wrong. This is actually based on $7 bushel corn. But what I did is I tried to plot kind of net yield per acre along the top, and then your net profit along the side. So how much money are you going to make after you paid for your cost of growing, like we looked at earlier in terms of cost of production, and your drying cost as fuel costs change. So right now, if you're paying 50 cents a liter for propane, current carbon tax is about 65 bucks a ton, $7 corn. Really, it doesn't make sense to try and grow a shorter season corn because if you can get more yield out, it's kind of worth it to pay for the drying for that. Even though it will cost you money, you will make a bit more profit. But as things change, so first of all, if our propane cost doubles to $1 a liter, now we're starting to shift downwards, and you can see the bottom of this graph is starting to get into the red territory. So there are some situations, especially some of the lower yielding crops that tended to be some of them tended to be a little bit wetter. If you had a wet yield and a low yield, you probably weren't making a lot of money if you're paying $1 propane. If our carbon tax increases, it doesn't actually affect the pricing that much. It shifts it down a bit, but not as much as you might think, because the carbon tax is only actually a small portion of the total fuel cost. It does make a difference though. But as our propane price continues to rise, if we get up near $2 or even $3 propane, then you can see this mass of samples is it's hovering around that $0. So certainly there's some corn that's still making a good profit, but there's lots that's not if we're having to dry all of that. So if we're seeing fuel prices increase to $2 and $3 a liter for propane, that's when you start to want to think about growing a shorter season variety of corn. If you're going to be able to harvest it drier, yeah, you might have a bit of a yield hit to that. But unless you're guaranteed that yield is going to be coming off nice and dry, you might be paying more than you think to dry that grain. So something to think about. It's not a surefire. Yes, it's always, if you're not making this many bushels an acre, then you should grow a shorter season corn. It's not that simple, but it's something to keep in mind is what is it actually costing you to grow your grain? How much profit are you making, and how much is drying cutting into that? You kind of have to do the math for your own operation, but as things get more expensive, it's going to become more important to look at that. So just in summary for this first half of our talk, we're about to get to our break. Couple of key things to remember. When you're harvesting, check and adjust your combine constantly. Make one change at a time so that you're getting the best sample you can, because that's going to set you up well for drying. When it comes to drying, essentially what we're doing is we're heating up air to reduce the humidity. In a heated air dryer, we're heating that air up a whole lot, and then we're pulling that grain out before it's equilibriized. If you're drying it in a bin, you only want to add maybe a little bit of heat or maybe none at all, because you're trying to target that 70% relative humidity so that your grain gets just nice and dry without over drying. Different dryers, really they all work well. So know what you have and know how to operate it well. And then if you're looking at upgrading things or making some changes from energy efficiency, first of all, know where your energy's at right now. Make some measurements, know what you're doing, and then look at ways to change it. For grain quality, the best way to manage that is lower your drying temperature. It will hurt your efficiency a little bit, but sometimes quality is more important than quantity. So it is important to keep that in mind. And finally, you can definitely use natural air to dry grain. or hybrid systems. And I do see there's a question in the chat. Do you save much by steeping the hot grain before cooling it? So that's thinking back to where you're putting it in a bin, letting it actually sit in the bin hot and not running a fan. You can turn a fan on right away. You won't get quite as much moisture out. The best gain you do get is by steeping it for, say, 6 to 8 hours. If you can do that, it does mean you need, a bin that you can leave that corn in and let your dryer keep going. So you have to have a bin that can do that. But yeah, you do save some by steeping the grain. If you don't steep it, you just put it in a bin and run the fan. It'll still take out moisture. It just might take out slightly less. I don't know, half a point less or so. So maybe instead of 2 points out, you get 1.5 points. So you'll still get something out. But if you can, steeping it is a good idea. Are there any other questions before we move to a break?
Just a comment again, James, there. We use those cold floor bins. We have a spreader in the top. So it's actually 2 cones. So it does make a very even fill, even though it is not perfect, but it does do the trick. At the Grain Farmers of Ontario meeting in our district was a presentation about using corn stover for drying. And I think there's a dryer in Mount Bridges that is doing that fairly successfully. I'm not a great fan of fires around the barn, but
okay, that's good to know, Simon. I appreciate that. Yeah, there's certainly some farmers that are looking at that. I mean, you've got stover in your field. If you can bale that and bring it to the farm and burn it, can be a fuel source. The advantage of wood pellets is it tends to be cleaner and easier to manage because it comes in on a truck. You don't have to harvest it yourself, but you do have to pay for it. I think with corn stover, you're paying for it in different ways, paying for it in the fuel it takes to bale it and haul it to your farm, and potentially you're paying for it in some lost nutrition, because then that biomass isn't left in the field to decompose and contribute to your organic matter. So there's trade-offs there too. But I appreciate that, Simon. All right, you've been listening to me for about an hour, so we're going to jump to a break. I do have a little video that's going to play. It's about 15 minutes, just kind of a fun little YouTube video that somebody who's not necessarily a farmer kind of learned all about grain bin construction and grain farming. So we'll watch that if you want. Feel free to refresh your coffee, go to the washroom, whatever you need, and we'll take a break for about 15 minutes. You can watch this video, and then we will come back at about, I guess it'll be about 20 after 2. And the second part is a bit shorter, so I'll leave lots of room for questions at the end. But I'm going to get this started, and I'll let you go to break. And if you think of something over the break, feel free to put it in the chat.
Holy cow, there's a lot going on here.
Oh.
Hey, it's me, Destin. Welcome back to Smarter Every Day. When you eat today, that food's going to get to your plate from a field like this. And before it gets in that field, it's going to pass through the hands and the wallet of a farmer like this. I say wallet because he has to use something more than likely called a grain bin. Today on Smarter Every Day, we're going to talk about the science, the engineering, the economics, everything that goes into using a grain bin to get food from the field to your plate. Trey, is it a really good thing to have a grain bin?
It is.
Why?
Oh, for logistics and economics sake, it buys you time getting the grain out of the field, and hopefully as the winter goes on, the basis improves and you can get a higher price for your grain.
Today on Smarter Every Day, we're going to talk about all that by building a grain bin and then figuring out how they use these things. Let's go get smarter every day.
These things are everywhere. I've always called them silos, but that's not exactly right. Now it's true, these tall skinny ones are silos. They sometimes contain a special type of feed called silage for animals, but these short fat ones, Those aren't silos. Those are called grain bins, and I've been on a quest to see if I can learn everything I can know about them. My farmer buddy Trey is also an engineer who went to Auburn University. We like to talk about mechanical problems he has to solve out on the farm. When he told me he was pouring a huge concrete pad for a grain bin that he was going to buy, I was intrigued. The foundation for this thing was 52 yards of concrete, heavily reinforced with steel rebar, and the more I thought about the forces this thing has to put up with, like wind blowing on the side of a huge structure, literally tons of grain on the inside, the scale of this concrete pad started to make more and more sense. Trey explained that these things are sold as a kit, kits that are engineered to be assembled on site by an expert crew. If you had a crew of only 3 people but no crane or tall ladder, how would you build this thing? It's over 30 feet tall and weighs several tons. The more I thought about this, the more I realized there had to be a simple, clever technique that I just didn't know about. So I decided to try to work myself onto one of these crews to see what I could learn over several days.
So what do you call that tool?
Punch?
Yeah? You're just using a punch for alignment?
Yeah.
What's your name, man?
I'm Danny.
Danny, I'm Destin, man. Nice to meet you.
Nice to meet you.
And what was your name?
Nicholas.
Nicholas. Nice to meet you, dude.
Pleasure.
You guys go all over the place doing this?
That's all we do, yeah.
Really? The way it's going to work is you're going to build this ring and then use those jacks to do what?
We'll bolt them jacks to these sidewall sheets, every other sheet, all the way around. Look at that center pump that right there, and we'll jack them all at the same time.
So it's a hydraulic pump? And so you just hydraulically jack it all the way around.
Thing up, and then we put another ring on, drop our jacks, connect to the next ring, jack it up, takes the next ring, just keep pushing it up.
It was immediately clear that there was a ton of work to do at this job site. So to earn the trust of the crew, I asked Danny, what is it that they did not want to do? And I immediately started doing that.
So I have learned if you want to work on a crew, it really helps to do the crap jobs, because once you do that, you kind of establish credibility, and then they'll let you do some of the bigger stuff. But right now I'm assembling vents for the top of the roof line. I just started working and they didn't make me go away. You know what's a big deal? Punches. Punches are a big deal because you stick it through one sheet of corrugated metal and you use it as a lever to align that sheet of metal on the back, and then you align it, and then you can put a bolt through an adjacent hole. Punches are huge. This is a fascinating engineering marvel. It's a fascinating process to assemble. And I always thought, you know, they're pretty in a field with a sunset and maybe a hay bale or something. No, I'm gonna think about engineering when I look at these from now on, and I'm gonna think about punches, because punches are the best. At least today, punches are the best.
Okay, we now have a completed grain bin. Now it's time to put grain in it. Trey called me out to the field a few months later when he was harvesting beans, and when I pulled up, he was offloading his combine into a truck. I asked him if I could jump in the cab with him while he finished the last few rows.
Holy cow. There's a lot going on here. That's a lot to look at, dude. That's a lot going on. You are mentally engaged this whole time, aren't you?
Oh, very much so.
See that instantaneous average is about, it's in the 70s now, which is pretty good.
Do you love this?
It's pretty fun.
This is pretty awesome. It seems like this is awesome when it's working right now, but it looks like there's a lot of maintenance involved in this.
Oh, there is. There's a lot of maintenance, and if it breaks, it's really aggravating.
That statement was prophetic because literally 15 seconds later, a shower came out of nowhere and it hit the field we were working on. Now, Trey said we should stop harvesting, but he didn't want me to drive back home without the good footage I wanted because I've been wanting to ride in his combine with him for years.
So why are you stopping when it's raining?
Oh, that's bad.
What happened?
I choked it down.
It was at this moment that I learned that something as simple as a 30-second rain shower can lead to huge problems for a farmer. Because the crop got wet and we didn't immediately stop harvesting, it choked out the combine, which made me feel a little bit guilty because I kind of got Trey into this situation, but not really, because I got to see something firsthand I've often heard about farmers. When a farmer has a mechanical problem, they don't wait for help. They know their equipment inside and out, and they grab a wrench or a tool, and they just start taking things apart and fixing it immediately. It's very impressive.
This is what's most impressive to me about farming. When you break it, there's nobody to call, is there?
No.
I won't lie, before I came over here, I was feeling sorry for myself because my lawnmower was bound up.
Sure enough, about 40 minutes of this, Trey and his brother Clay had everything figured out and working again. Anyways, back to the beans. Here's how Clay was getting the beans into the grain bin.
How long does this take?
About 10 minutes, 15.
10 minutes, you'll get a whole bucket up? I mean, a whole truck up there?
Yeah, maybe 20, just depends.
Yeah.
So this truck can hold around 400 bushels of soybeans, some of which got rained on. And the grain bin we built can hold 48,000 bushels. So if we use this auger and we put these wet beans in with the dry beans, how do these wet beans not spoil the whole harvest?
So one of the most important things that a bin like this can do is dry the grain, is that correct?
That's right. This fan blows the air up in under the plenum in the bottom of the bin and then up through the grain.
That's a beast of a fan. Can we hear it?
It is, we can.
Dude, that thing's eating some air, man.
It is.
So Trey mentioned a plenum. Remember that flooring they put in when they were assembling the grain bin? That's what he's talking about. It's got holes in the floor that are just big enough for the fan to blow air through, but not so big that grain falls through it to the bottom of the grain bin. That means the entire floor acts like ductwork to evenly distribute the air through the grain. When the beans are first loaded into the bin, because it's straight out of the field, the moisture level might be too high to store long term. Things like mold or fungus could be an issue. In order to increase the storage life, the moisture has to be brought down. The fan blows to the bottom of the grain and then moves up through all of the grain all the way to the top. As the air passes moist grain, the skin or the shell of the bean gives off some of that water content, and when the air passes it, it raises the humidity of the air. Let's take a look at one individual bean. The outer skin is permeable, meaning moisture can pass through it. As long as the moisture level of the air passing by the bean is significantly less than the moisture in the bean, water will exit the bean and drying occurs. As air absorbs more and more water, at some point it doesn't want any more. That air then continues to move up towards the top of the bin, but now it has more water in it, so something interesting happens. This is essentially what farmers have to deal with. The bottom of the grain bin is going to dry first because that's where the moisture to bean balance ratio is, and the top of the grain bin is going to dry last. Because the air can only contain so much moisture, there's only going to be a 1 to 2 foot section of the beans that are drying at any one time, and that's going to start at the bottom and move all the way to the top. And the farmer has to know when his beans are dry, because if he gets it wrong, he starts losing money.
So how do you make money? You sell grain based on what?
Based on weight.
Weight. So it's not to your advantage to dry the grain out too much because it loses weight.
That's right. So you dry it for storage, and then you would sample it, and if it's too dry, you could cut it on when you got high humidity and add moisture back to it.
How do you measure the moisture in the grain? Is it just like by feel?
with a moisture tester.
What? Really?
It's just,
You got a gadget?
we've got a gadget.
Yeah. All right, let's go look at the gadget. How long does it take to? It's testing.
These are 11.4.
11.4%. How did it do that?
I don't know how that works.
What's an ideal moisture level
I
in your
think
beans?
12 or 12 and a half. I'll have to look. I can't remember.
So if you get paid per weight of the bean,
Right.
but it's measured in volume.
Trey showed me a little tool called a test weight scale. You fill it up with beans and it gives you an idea for the weight of your crop based on the packing factor.
So as a farmer, are you trying to hit a certain moisture level and size of the bean? Because it's a trade-off between packing factor?
Bigger beans are better. They
Okay.
make you more yield per acre, more bushels per acre the bigger the bean.
One of Trey's neighbors is a farmer named Jeff with a much larger operation, and he happened to be selling soybeans that day, so we went down to his farm and watched the trucks get loaded up.
So the ultimate reason to have a grain bin is he's selling this grain now that it's at a premium price, right?
Correct.
Yeah. Okay, so this is a whole 18-wheeler. Look at this. Did you get a good price? He said he hopes he got a good price.
Because the grain bin was almost empty, Jeff and Trey let us go inside and get a better look at how the mechanics work.
The sweep's going in there. Do you want to film that?
Yeah. Holy cow.
Trey explained that once the grain falls due to gravity, there's an auger that crawls around the floor and pushes the grain towards the center, where another auger that's built into the floor can push it out so it can be loaded onto the truck. He also explained that the inside of a grain bin is one of the most dangerous places for farmers.
So you can get down in it.
Right.
And it can entrap you.
Right. And so you get caught up in that grain as that wall flaps in, and either one gets suffocated or two get wrapped up in the auger. It would be a bad way to go.
So this is a pretty dangerous place to be.
Right. And so that's why we're here. That's why we don't walk over there. And as well as if this bin was full, you wouldn't want to walk across the top of it if it had been dried or crusted over or anything like that, because it could collapse.
Like voids in the middle of it?
Mm-hmm. Yep.
That happens?
That happens. And also a lot of times people will get in these bins when they're augering this out, they get stopped up and try to get it unstopped or something like that, and then it'll cave in. You'll get moving grain and you get sucked in like quicksand.
We were able to enter this grain bin because it was almost empty and we were walking on the floor, but I'm really glad we could because it gave me a moment to reflect. Grain bins are super important. They're one of the most important tools for efficient farming and for the security of our food supply. And as you know, the key to keeping grain bins like this full, it's farmers. Farmers are the backbone of America.
What I'm learning about farmers like yourself, Jeff, is that you guys are good at meteorology, biology, right? Math. You're good at engineering and making stuff work in the field, and economics. So you guys have to do everything.
Pretty much.
But
We may not be good at it, but we have to do some.
I've noticed every farmer that I say that to.
Accounting.
Accounting. Every farmer I say something to, they say that immediately after I mention how difficult their job is. They always say, "Yeah, but we ain't good at it." Blah blah blah. Y'all are sandbaggers, is what you are.
Yeah. Well, you hire people. I got a guy that helps me with my marketing. I got a good accountant. You pay people for their services that are good, and then you try to make the rest of it work out.
So you guys are businessmen like no other. There's no other job in America like this, is there?
I don't know. I stay on the farm.
That's awesome. You guys are good. You all are sandbaggers. I'm convinced that farmers are the smartest people out there, but you like to pretend like you're not.
We're not very smart.
Whatever. I hope you enjoyed this episode of Smarter Every Day. I hope you appreciate farmers. Please consider subscribing.
All right. Hope that was interesting for all of you. Hope the video and sound was okay over the connection. Just looking at some of the questions. So I'm gonna see, one question about a stirrator. Is it a good idea to add cold air during the winter? So we're going to talk about that in this next section. So I'll hold off on that question. If I don't answer it, come back to me. What's the easiest way to see how many fines are under your full floor? A really easy way these days, we all have one of these in our pockets now, right? So I would say cut a little hole in your floor. It doesn't need to be much bigger than your hand to fit down. Take your phone with your camera on it, stick it down in there and spin it around, take a little video or pictures down there, you can pretty quickly see what things look like. How deep till you should clean it out? I don't know, how deep is it? I mean, if it's half full of fines, you probably want to clean it out. I would say too, if you're going to cut a hole in your floor, do it away from the fan, because near the fan, you're probably going to have a lower amount of fines just because that fan is going to be, there's going to be more air there. So kind of do it on the opposite side of the fan, I would suggest. How it costs to get it cleaned, I'm not sure. How do they do it? Essentially, you can pull up the floor to do it. You might be able to get a grain vac in there underneath the floor, but you want to be careful because you'll be knocking over all the floor stands. One of the best ways to do it is pull up the floor, but that's a lot of work. I have seen bins you might be able to get from your supplier. I've seen bins where you can actually get like a bolt-on door that goes below the floor. So you have 5 or 6 of them around the plenum, and then you would open that, you could unbolt that door, open it up, and that would just like blow the fines out when you turn the fan on. So that can be an option too. I would say if you've got a bin that, like a drying bin where the grain is coming in and out all the time, that would be the bin I'd check first. If you've got a bin that just you kind of fill once a year and leave it, you're not going to have as many fines underneath that bin. So you need to think about that too. But that's a quick and easy way to check, is just cut a small hole. You can patch it with a piece of tin. Really easy. You're not going to compromise your floor too much by doing that. So just cut a small hand hole, stick your hand down in there with your phone camera, and you can get an idea of what things look like. All right, let's move on to the grain storage section. We kind of kicked it off already with some of those questions. But if you have more, please throw them in the chat. And I will get to the cold air during the winter question in a little bit. So really, I want you to keep in mind that when it comes to storing crop, there's really only one rule, and that is that the grain quality that goes into the bin is probably about the best that it's going to be, but it can sure get a lot worse in the bin. So that's the trick to grain storage, is trying to keep it from getting worse. And that's going to be the focus of the next about half hour that we're going to go through here. Just wanted to show you for interest's sake, in Ontario, we've been building an awful lot of grain storage. In fact, we build about, well, what is this? About 20 million bushels a year of new grain storage is what you're seeing on this chart. Stats Canada keeps track of this. So this is from 2021. I haven't got the most recent data. But overall, the trend is, yeah, sorry, there you see it, 16 million bushels a year on the chart. On Ontario, we've got about almost 500 million bushels. It probably is 500 million bushels of storage now on Ontario farms. Commercially, we've got about half of that. So there's a lot on commercial elevators, but there's an awful lot of grain being stored on Ontario farms. And that's why we're here, to try and help those of you with grain storage manage your grain and storage well, so that at the end of the day, you can still get the value out of it that you're hoping to get. How to store grain safely and well? Well, it starts with good, clean, quality grain like we talked about. We spent the last hour talking about drying. Then you really want to keep it in condition, and that's aeration. And we've got a whole section on that. And then also keep your eye on that grain. You want to monitor it, because of course you put your grain in that bin. I mean, was a 1,000-ton bin at $7 a bushel, that's $250,000 easy. So you probably want to keep your eye on that. If I had $250,000 under my bed sheets, you best believe I'd be looking at that once in a while to make sure it was still there. So if you've got grain in your bin, you want to be doing the same thing. Bad stuff happens when grain gets warm and wet. That's what you see on this chart. We've got temperature on the bottom, moisture content on the side. And the message here is that you want to try and keep your grain cool and especially dry. Because if you don't, if you start to migrate upwards on this chart, in either direction, you start to get spoilage. If your grain gets too wet, you're going to be running a real risk of mold getting in there. Mold is going to grow in damp conditions. Pests really like the warm environment, especially if you're storing seed. You're going to start to impact your germination really, really quickly. So cool and dry, that's really the message here on this chart. How long can you store it? Well, it depends on the crop, but this is kind of related to that question about storing, adding cold air during the winter. So the length of time you can store grain at different moistures and temperatures, there can be huge variation. This is for corn. There are similar charts available for soybeans and wheat. I don't have them in this presentation, but I can get them to you. And the number on the chart is the number of days. So what this means is if you've got a hot September day, you're harvesting corn, say it's 25 degrees out and your corn is wet, 30 degrees or 30% humidity, because it's, you know, September and you're getting the early crop off. That corn, you're not going to be able to store it at those conditions for longer than about 3 days before you start to see significant spoilage in that grain. Now that same 30% corn, if you cool that down right around freezing, like 2 degrees, that's you can store it for much longer, 40 days, but you're still going to get spoilage. Really, the message is if you've got wet grain, you need to cool it down. But even very dry grain, say 16%, I know that's not fully dry for corn, but 16% corn, I mean, you can store that for 3 years if you can keep it at 2 degrees, but you can only store it for 30 days if it's up around 30 degrees. So the temperature and moisture both have a lot to do. This is why if we're doing natural air grain drying, you want to be really careful. That's why you want high airflow in those bins, because if you've got wet grain, especially if you're much above 20%, you're simply not going to be able to keep that grain in the bin long enough, or it's going to take too long to dry it before the spoilage starts to set in. So if you've got really wet grain, natural air might not be the right option. It's a good idea to take out the highest points of the moisture with heat, and then maybe you can finish it off in a natural air bin. But keep this chart in mind, because this kind of helps you understand, okay, what's my grain at? What's the temperature? What's the moisture level? How long is it going to be? How long am I safe before I'm going to start to see some spoilage in that grain? And I should say this is for good quality grain. So if you've got bad quality grain, these numbers are going to go down even more. You've already got lots of fines or lots of breakage in there. You're not going to be able to store it maybe even for half of this length of time. How dry do you need to make it? Well, I mean, we all know the moistures we need to sell it at, and that equates roughly with the short-term kind of 6 months or less storage. The reason for that is that at these moisture levels, that equates to a relative humidity in the air around it of about 70%. This is really the upper limit of humidity that's going to prevent mold growth. So if you get humidity higher than 70%, that's where molds and fungus really start to set in and grow. So if you're storing longer term, that's why you want to dry it down even a bit more, because you want to get that relative humidity within that grain mass. You want to get that down to like 60%, really to provide that buffer against mold growth. So if you are storing longer term, you do want to take it down, like beyond the summer, I mean. If you're storing it into July, you're probably okay. If you're carrying it through to the next fall, maybe for feed or something like that, you probably want to take out a couple of extra points of moisture to make sure that it's safe in the bin. Aeration. This is really the only tool that we have to manage grain once it is in the bin. Once we've put it through a dryer, sure, you can maybe take it out of the bin and stir it up, put it through a cleaner, but in a bin, to keep it in condition, we've got our aeration fans. We're doing it for a few reasons. First of all, as we saw in the video, we want to take the heat out of the grain, the warm grain coming in from the field, we want to cool it down. And we want to equalize the moisture throughout that grain. So we can dry it down in a bin, it'll be slow, but if there's only a couple of points or if the moisture is a bit uneven, we can definitely do that in a bin. We want to maintain the temperature for long-term storage, especially as the season changes. And we'll talk about that in a little bit. And then we also want to keep, the other reason we want to keep the grain temperature consistent is to prevent air from moving around inside the bin. Because if we get hot patches in the bin, we're actually going to see air moving within the bin. You'll see moisture moving from that air. You can get spoilage happening really quickly. So first of all, aeration obviously does cool the grain down to whatever the temperature of the air is. So a good way to do this is cool it at night. If you've got grain that's already nice and dry, you don't need fans that are very large. If you're expecting to have grain that's a bit tougher, you might want to invest in a fan that's slightly larger. And I'm talking about CFM, which is an airflow measurement. It's cubic feet per minute of airflow. and what I'm showing here is per bushel of grain. So if you've got a 10,000 bushel bin, you've got a fan that does about 5,000 CFM of airflow, then you've got about a half a CFM for every bushel of grain in that bin. That's simply what we're talking about here. And you can get the airflow ratings from your fan from the fan manufacturer, and I'll kind of show you what that looks like in a minute. The last thing that you can be aware of, if you are planning to do natural air drying, you want to have a much higher airflow. Now, the times you're seeing on this chart, this is the time to change the temperature of the grain. It's not the time that it's going to take to dry. That takes a lot longer, but the temperature of the grain is going to change fairly quickly. So this can give you an idea, if your grain is already good and dry, how long is it going to take you to cool that grain down in the bin for that kind of temperature front to move through. Obviously, a bigger fan, it'll go faster, but even a small fan, you can do it within a few days. So it's very workable. Now, keep in mind when you're looking at your fan, it's not always pushing the same amount of air. The airflow of your fan is really dependent on how much resistance it's encountering. This is influenced by how much grain is in the bin, how deep is the grain, what type of grain, and what type of fan. What you're seeing on this chart here and in the table, I've got 4 different types of fans listed. So the way that they measure the amount of work that a fan has to do, it's called static pressure. They measure it in inches of water, which is maybe something you're not super familiar with. We're more used to measuring pressure in PSI. Well, an inch of water is only about 1/28th of a PSI. So we're talking very low pressures here. And it doesn't take a lot of pressure to really stall out a fan. But as you can see, an axial fan produces, that's basically a propeller fan, produces a whole lot of airflow, but doesn't have a lot of pressure. So it dies off very quickly. A centrifugal fan can push a lot more pressure, especially a high speed one, but not as much airflow. So depending on your bin configuration, might lend you towards one fan or another. Drying bins tend to use axial fans because they want an awful lot of air and they're not usually dealing with a lot of grain. A big, tall storage silo, you're going to want a high-speed centrifugal. But know your fan. You can get the chart from your manufacturer and find out how it performs at different pressure levels. Now, if you're not sure how much pressure you've got in your bin, one way to do is figure out how deep is your grain going to be and how much air are you going to have. This chart kind of represents that in a way. Now, it just gives an example of different grains at the same airflow, 1 CFM per bushel. You know, a canola bin packs a lot tighter than a soybean bin. So you're going to get a lot less airflow in a canola bin, or you'll have a lot higher pressure for the same airflow in a canola bin. But you can measure static pressure actually pretty easily without using a chart like that. Just slap a pressure gauge on the side of your bin. You can get them in inches of water, like this one. You bolt it on there, silicone it up, and when you turn your fan on, you'll get a sense for what the pressure is. But if you can't find that, or you're looking for an even simpler solution, just get a clear hose, fill it with water, and plug the one end into your plenum. And when you turn on the fan, what you'll see happen is actually that moisture level or the water level in the tube is going to change. The height differential, that's literally your pressure in inches of water. That's literally what it means. There's a very cheap way to figure out how much pressure is your fan seeing, and then you can get a sense based on the manufacturer's chart for how much airflow it's actually pushing. There's also a tool that you can use to estimate this online, and I'll show you that in a few minutes. Once you've filled your bin, and I know somebody earlier was talking about grain spreaders, you do want to try and spread out those fines if you can. So if you don't have a grain spreader, I would highly suggest coring your bin. What this means is taking out a load or two of grain. As we know, grain bins tend to empty from the center. They've got kind of a funnel flow. So what you'll end up doing is taking out that central core. That's where the fines collect when you're filling a bin, just based on gravity. They don't go as far to the outside. So by pulling out that central core, you're pulling out the bulk of the fines. Then you can either feed those fines to your livestock if you have them. You can clean just that section, put it back in the bin. You can sell that at for feed grade. Coring doesn't work well in hopper bins because you don't get that funnel flow. So keep that in mind if you got hopper bins. But definitely coring the bin, you need to do that because that will even out the grain within your bin. Now, if you've got a grain spreader, that's going to work to kind of spread out the fines already. So coring isn't really going to provide you the same benefit. But if you don't have a spreader, coring is I would say it's a must, because if you let those fines stay there and they set up, you're going to have much lower airflow through that center core. That grain's going to stay warm. It's going to stay wet longer. And you could wind up with a big pile of spoilage in the middle of your bin, which is not what you want when you go to ship it out. The profile in your bin also affects that we talked about, kind of leveling it out and how that's going to make it take a lot longer to aerate and dry. So I know it's a bit of work. Coring the bin is going to help start that process, because you'll end up with a cone down in the middle. So it'll be easier once you've cored the bin to level it out. If you've got a grain spreader, you can get in there with a rake and push it around a bit. Or if you've got some children or grandchildren that need something creative to do, you can put them in there with a shovel. I know I spent many hours on the business end of a shovel in my dad's grain bins. Of course, we have to be safe, and I'll talk about that in a bit. But with a bin that's just been filled, hopefully there's no voids, there's no spoilage. So getting in there and leveling it out, it's a less risky proposition in a bin that's just been filled than one that you've been emptying. But we do for sure need to be safe when we're in a bin. I want to talk for a minute about what happens to the moisture that's in our bin, because of course the grain in the bin, it still has moisture in it. 15%, we call it dry, but it's still 15% water. And what can happen is that as grain bins, they're big metal containers, so we know metal transfers heat pretty well. As the weather cools down in the wintertime, the grain near the wall of that bin is going to get cold, and that the air amongst that grain is going to get cold too. And so what happens is the moisture is going to condense out of that grain and out of that air. It's going to fall to the bottom. It's going to get picked up, and that grain in the middle is still going to be warm and wet. So that's going to create air cycling in your bin, and you'll wind up with condensation in the attic space, because that's where the moisture is going to gather. So if you ever open up a bin and you see there's moisture on the inside of the roof, that moisture has almost certainly come from the grain. It probably has not come from the outside of your bin. It's come from inside. That means you've got this kind of situation going on. You'll wind up with a wet zone in the top center of your bin, and that's where the spoilage is going to start. So to avoid this, you want to be cooling your grain down. You want to keep it relatively close to the outside air temperature, because then that minimizes the chance of this moisture movement. And also equalizing the temperature throughout that bin. If there are some hot pockets starting to form, running the aeration cycle once in a while will help keep that in check. Now, the opposite problem happens in the springtime. Of course, sun shining on a nice metal tin can in your yard is going to heat up that grain on the outside, but that cold grain mass in the middle, you'll wind up with the moisture collecting down at the bottom of your bin. Really not where you want it, because you won't find that until you go to empty the bin, and you won't be able to empty it because you'll have a bunch of grain set up. So same thing, running your fan, keep that temperature equalized can help prevent that. I know in some larger bins, some farmers are experimenting with keeping the bins frozen in the winter or even into the summer, and that can work in a large bin. In a smaller bin, that's really hard to do because your surface area to center mass is pretty high. But the bottom line is, when we're looking at conditioning the grain in a bin, so as the temperature of the outside air generally goes down over time from August, September down through December, it does cool down. And so you do want to be running your fan, cooling that grain down about every time you see an average temperature change of about 5 to 10 degrees. That means you'll probably have 3 to 4 aeration cycles over the course of the fall. At least. And so if I show my little animation here, as the temperature of the sun drops, you aerate, and then your grain temperature drops. Now, when you get into the springtime, especially if you're storing that grain longer term into July, August, you probably do want to be warming that grain up at least above freezing, but you want to try and hold that grain at 5 to 10 degrees if you can. That means aerating at night, keeping it cool and dry. You don't want to keep it too cold, because having it frozen, you might actually get a lot of moisture condensation in there in the warmer months, and that can cause mold. But warming it up to 5 to 10 degrees can help to hold it there. So you'll need several aeration cycles through the fall, and then in the springtime, yeah, try and keep it as cold as you can. It's not always possible, but you want to do what you can. Because keeping it cold and dry, that's the recipe for storing it long term. And as I mentioned, you want to be checking on your grain. So check on it regularly, like every couple of weeks in the warm weather for sure. Maybe a little less often once it's frozen down, but you definitely can cool your grain right down to freezing or even below. It doesn't hurt the germination. You can store it. Actually, there was a study done that I don't have the data for in here. I think it was in Japan, and they froze beans down, and actually the germination was still good after 10 years for beans that were frozen solid. So it doesn't hurt the germ. If the grain's in good quality, you can definitely freeze it down. But definitely be checking your bin, use your eyes. You know, we know what good grain looks like. So are you seeing signs of spoilage, dust, insects? Are you smelling anything that's a bit off? If you can smell it, move it. It's probably too late. And certainly keep written records of your inspections. Now, if you have a monitoring system in your bin, maybe some of you do. These are typically cables that hang down from the roof of your bin. They'll tell you the temperature, the moisture. You need to keep in mind that they're telling you what's going on right around that cable. So grain that's 2 or 3 feet away from that cable, it's going to take a lot longer for a problem there to be sensed by the cable. So a cable doesn't replace manual checks. It just helps you have a bit of peace of mind that in between your manual checks, you know that things are still in good condition. You can also use cable systems and integrate them with your fans so that instead of trying to turn a fan on and off to dry that grain down or run your aeration, you can set it up and it'll run the fan automatically when it knows that the moisture level is getting a bit high. So that's one way that you can automate things. And if you're thinking about doing that kind of work, or you're wondering, okay, we've talked a lot about storage, I'm not sure, how do I know when I'm going to get the best drying potential out of my fan? Well, there are some tools, some online tools you can use that can help to show this. So if you don't want to remember that equilibrium moisture chart that I showed you earlier, what you can do is go to decisionfarm.ca. They've got a tool on there called BinCast. Now it's moved around a bit, but right now it's being housed at decisionfarm.ca. It was developed by Weather Innovations, which is a company out of Chatham. And this tool essentially tells you when it's going to be a good idea or not to run your fan. So you go on this, you tell it the location that you're at. You can pick your farm on a map, and then you tell it the grain that you're storing. So in this example, I've chosen corn, and it gives me an hourly weather forecast. I just did this on Monday. Gives me an hourly weather forecast for the next 5 days. Every hour, what's the predicted temperature and predicted humidity level, and then what's the moisture that my grain is going to reach if I were to aerate it at that conditions. So you can see that on Monday of this week, from 1 to 3 p.m., my grain, if I was aerating, it would be, really good moisture, 13, 14%. As the day went on, the humidity was creeping up. The temperature went down a little bit, but the humidity was starting to creep up. That means I probably want to turn my fan off around 4 p.m. that day, because otherwise I might be adding moisture back to the grain. Yeah, you can. I see a comment in the chat. You can do this with a humidistat. So if you dial in your humidistat for like 65%, then you're going to turn your fan off before you get upwards of that. So that's a really good tool, a really simple tool. You can integrate that with your fan. If you don't have a humidistat, you can use something like BinCast. If you've got a weather station, I would recommend with a humidistat too. Like it's good to have a weather station on your farm or close by, one that you know is reliable, so you can keep track of this too. There's a couple other tools I want to make you aware of. We've just launched one in OMAFRA. It's called, well, it's part of AgriSuite. It's some of you may be familiar with AgriSuite if you've done any work with nutrient management. We've just added a new tool to AgriSuite focused on greenhouse gas emissions. And really the purpose here is to help farmers understand, first of all, where do greenhouse gases come from on your farms, and what can you do about them? So there's a whole other presentation of this. I'm not going to get into it, but there is a component of this tool that lets you look at a grain dryer. So you put in how many bushels you're drying, what's the moisture level. It will estimate the amount of fuel that amount of grain is going to take. And it'll also give you some recommendations of different things you can try, including dry aeration, which is that steeping and in-bin cooling that we talked about, including optimizing your burner, including adding a heat exchanger if you don't have one. And what you'll get is an estimate of the emissions, the greenhouse gas emissions from burning that fuel, and how much you're going to save. And actually, if you click on that button that says details, I don't show it here, but it'll actually show you the actual fuel quantity too, in whether it's liters of propane or cubic meters of natural gas. So it's an estimation tool. It's pretty high level, but it can help you get a sense for some of these modifications we've talked about in terms of grain drying, what difference they might be able to make in your particular situation. One more tool I wanted to make you aware of. This one comes out of University of Minnesota. It's their bin fan calculator. And what this can do is help you estimate the airflow in your bin. So you put in your bin diameter, your grain depth, the type of crop in your bin, and it will predict roughly how big of a fan you need based on the airflow you want. So if you want 1 CFM per bushel, in this particular bin, I'd need about 12 horsepower worth of fans. Now, further down in the tool, you can actually tell it what fan you do have on your bin. It will tell you what your airflow actually is and what your airflow is at different grain depths. So again, if you're planning aeration, you want to know how long it's going to take or whether or not your bin is set up well for drying. You can use a tool like this to kind of estimate what's the performance capability of your fan. Or if you're building a new bin, how much fan are you going to need? So a really simple tool to use. It's a great one to play around with if you're at all considering that. Wanted to touch lastly on safety. So it's really important to keep in mind safety. We talked about it briefly earlier. There's only one you, obviously, and so you want to be very careful when you're going into a bin. According to the Canadian Agricultural Safety Association, roughly 3 to 4 people every year die from grain bin entrapment. It doesn't sound like a lot of people, but there's only something like 50,000 farms in Ontario. So how many farmers, what percentage, 3 to 4 people, that's actually a pretty high percentage. I know there's more farmers than that in Canada, but as a percentage of the number of farms out there, it's not insignificant. So there's a lot of common sense that goes on here. Basically, the moral of the story is never enter a bin while the auger's running without telling someone. If there's grain that's bound up in there, please wear proper safety harness and line, not just a rope tied around, because you'll get trapped in grain faster than you can blink if something breaks through. So please don't enter the bin. If you absolutely have to, see if there's a different way that you can do what you need to do. Keep yourself more secure. We all know we do have to enter bins from time to time, but make sure you're taking proper precautions because you don't want to find yourself trapped. And certainly never go in the bin with the auger running because you can get bound up in that. You might think you're okay. You might think, oh, it's going to be fine. But again, things collapse, things break free. I don't want to be reading your name in a paper someday that this happened to. So please be careful. Wanted to close off by just highlighting a few interesting innovations, and then we'll have some time for questions if there are any. First of all, some of you may recognize this. This is Stanton Farms. It's a digester near Ilderton, Ontario. And actually they are now, they've installed a natural gas upgrader. So they're producing biogas from dairy manure, but also they are upgrading their biogas to be pipeline quality, and they're pumping it into the pipeline. As a result, the town of Ilderton is probably one of the greenest towns on the planet right now because they are getting their natural gas and their electricity from Stanton Farms. So if you've got a digester near you, or you've ever thought about a digester and you've got enough manure to make it worthwhile, you probably have to import some off-farm materials too. Like I'm not necessarily recommending that for a small-time farmer. These can be a lot of work, but there is a business case here, and there are people that are doing it and doing it successfully. Radio frequency drying. This is kind of a new drying method, or newer drying method. In conventional drying, we're blowing hot air at a grain. We dry the outside of that grain out, and then the moisture stays in the middle, so that moisture's got to migrate to the outside. With radio frequency drying, it's not that much different than your microwave at home. You are blasting radio waves into the grain, and you're actually heating the inside of that kernel first rather than the outside, which means that the grain dries kind of from the inside out. Now, there's a company called DryMax out of the US. They are working on this. They've done it with wood chips. They're working on it with grain. It's quite a bit more expensive than a conventional grain dryer, and it's a bit still in kind of the pilot stage. They're looking for partners to scale up. But if you're looking for something innovative, I'm certainly keeping my eye on this one and seeing where it goes. Something else that's coming, there's a company that's producing ammonia on farm, or producing the equipment to produce ammonia on farm. The idea is you can take water and hydrogen from water, nitrogen from the air, feed it with sustainable power. Now they say it takes about an acre worth of solar panels, so it's not insignificant. But if you can produce fuel and fertilizer on your own farm, because you can burn ammonia as fuel, there is a business case there. I think they've got a pilot system set up in Manitoba right now, and it'll be interesting to watch whether or not this ends up being cost effective, especially as fertilizer and fuel prices continue to rise. Something else I think is really neat, coming back to kind of grain storage. This technology was developed out of Winnipeg a few years ago, and GSI bought it. It's basically they put sensors around the inside of your bin, kind of like an MRI scanner. And what they're doing is they're scanning for water within your grain mass. So instead of moisture cables, what you're seeing is this visualization of where the moisture is in your bin. I'm not sure if GSI is still, at one point you could buy this. I don't know if they're still selling it or not. I couldn't figure that out. GSI did just release a new system called Grain View, although I believe it's still a cable-based system. I hope they haven't done away with this entirely, because I think it's just a really neat concept, being able to see kind of everything that's going on in your bin. And the last thing I wanted to show you from a safety perspective, maybe you've seen this if you're on Twitter, it's the Grain Weevil. This is a robot. It's probably the size of a small lawnmower. So it's maybe bigger than it looks in the picture, but it's basically got 2 augers for wheels, and it drives around inside your bin, breaks things up, prevents you from needing to get into the bin. Because of course, if this thing gets bound up in the auger, it might get wrecked, or you got to replace some parts, but nobody died. So I think this is a really neat innovation from grain safety standpoint. It'll be interesting to see what they do with this, if this takes off, but if you can prevent yourself getting into a bin, I think there's definitely a business case here. So just in summary, from a grain storage standpoint, first of all, you want to keep your grain cool and dry. That's message number 1. Cool and dry. The cooler and the drier, the longer you'll be able to store it. Aeration is the tool that we have. So you use your fan to cool the grain down, keep that moisture equalized. If you haven't run your fans in a while, turn them on, cool that grain down, keep that moisture where you want it to be. And you do want to be running those fans when the outside temperature drops, say 5 to 10 degrees. Now, sometimes we get cold snaps or cold spells. I'm talking about kind of the longer term average, but keep that kind of 5 to 10 degrees in mind. You want to, and if you've got a moisture cable in your bin, you can very easily keep track of the grain temperature and the outside temperature. There's some online tools you can use, so please take advantage of those. I think they're great to help with decision making. BinCast, our new GHG tool, and the bin fans tool from University of Minnesota. Safety, obviously never enter the bin when the auger's running, and don't enter unless you absolutely have to. And then I think robots are coming to a farm near you, so it's going to be interesting to watch that. Not only in the grain bin, I think there's lots happening in terms of robotic weeding, potentially spraying, even seeding. So there's lots of innovations in that sector that I think are going to be really interesting to watch in the next few years. So any other burning questions? There's talk about carbon tax being removed from drying. Yes, so that's at the federal level. There is a bill that's passing through the House right now. I'm not sure if it's fully passed. Then it'll go to the Senate. They're looking at, I think it's a private member's bill proposing to remove the carbon tax from grain drying fuel. I don't know how that will be implemented. So like that's happening at a federal level, but yes, there is a bill passing through right now. There was one under the previous government, and then it died when there was an election called. So as we all know, just because there's a bill doesn't guarantee there to be a law, but if it goes to the Senate, they'll study it, there'll be committee. It's important to note though, I think the bill only captures grain drying happening on farms. So if you're a commercial elevator, I'm not sure if it applies to you. Something to keep in mind. But again, it's federal, it's outside my jurisdiction. That's the little bit that I know about it.
Any other questions for James?
I do have a slide with some additional resources here. So, and I'll send Lori a copy of this. I see I didn't necessarily update the slide title on all of my slides. Whoops. But I'll make sure Lori gets a copy of this. I don't know if you want to send it out or how you want to manage that, but I'm very happy
Sure.
to share these slides with anybody that's interested. I also do have a survey here, and I'm just going to see if I can pop this into the chat for you. I would love it if you could just go to this link. If you know what a QR code is, you can snap a picture of that on the screen. It'll take you right there. And I'm just going to try and put the URL in the chat right now. It's just a little survey to help me understand kind of who's attended this course right now, what you found useful, maybe how I could improve it. And so it's not very long. I'd appreciate if you could take just, maybe 2 or 3 minutes now as we're wrapping up to do that. So I just put the link in the chat. Hopefully that works for you. If it doesn't, please let me know, because I just kind of typed it in there, but it should work. And then finally,
Sorry, I'm not very handy with that stuff, James. Maybe if Lori puts a question or an evaluation on the computer, on the email, that's handy for me. So
we can send it out by email too, Lori. I don't know if you have your own evaluation. This is just one that I created, but
we have a little one just to get ideas for next year, but we'll make sure to include this one as well.
Yeah, it's specific to this. I mean, a couple of the questions that we addressed up front were like, how big's your farm? Because I just want to get a sense for who was on it and kind of where you're at in terms of your grain storage. But if you can see the chat, Simon, you should just be able to click on the link that's in there, and it'll take you straight to that survey. And otherwise, we can make sure to email it out. And I'm just going to move to my last slide, which shows my contact information. So I'd be very happy to, if you've got questions down the road or anything like that, you can always feel free to reach out either by email or phone. Both of those work very well for me. And certainly if you're not sure, Lori knows how to get a hold of me as well.
Any final questions for James? Simon?
No, just a comment. I was just at the Sprucedale meeting this morning for a little bit and talking to somebody there, and I told them that this will be available later on in demand. Is that true? Okay, so I didn't lie to her. So there'll probably be some people watching this. I find it very informative, and yeah, with a lot more agriculture moving north, and I think there will be need for, I think, smaller, like, and I know in our own case, I always figured the money we spent on running our fans in the winter would more than pay for the trucking that we have to truck it down to a local elevator. And so for us, we find it very attractive. If you come on thousands of tons of corn, no, cold floor beans are not the thing to do. Like you gotta do hot air, and that's just the way it is. But with of course the price of energy, the way things have gone, it's not a simple thing to do. So and we use our fans all the time, like for small grains and corn. Beans are terribly hard to drive with cold air. It doesn't really work. Wheat is for wheat we have turned the fans around actually in the summer. Like it sucks it through, and it seemed to do a better job that way. So there's just a couple of little remarks that I can tell you. But what I see on like I know we have one 32 or 3,000 bushel bin and a 4,000 bushel bin. The 4,000 bushel bin is lots big for cold air, like unless you had a bigger diameter. But with one ring more, it doesn't seem to dry the center just the same as with the 3,000 bushel. So that is just practical findings that we have learned. We have learned the hard way how not to do it. Like that.
Yes, yeah.
Over the years.
And that's an important point. Like this, we can sit here and talk in a presentation, but it's your own farm, your own setup, the fan that you have, the bin that you have. I mean, there's so much unique about every farm that it really is that there's an art to it. It's not trial and error exactly, but you do have to figure out what works, what doesn't. That's why, doing things cautiously, not just cranking up the temperature 50 degrees right off the start, but, you know, taking small steps and trying things out, you know, put a bit of grain in a bin and see how it goes as far as cooling that down, or trying to dry it with natural air, like you're talking about, Simon. You know, don't ram your bin right full and expect it's going to work for you the first time. So
it doesn't work. It doesn't. It doesn't work. That's what we have learned. And yeah. So anyhow, and then again, yeah, you mentioned that too. Like the sun beating on the steel granaries, it warms it up. Like that is just a fact of life. And even in the last couple of years, you know, been really good years for growing crops. Like and getting them off and whatnot have you. But I know you're hair isn't quite as gray as mine, but 1992 was a terrible year for crops, and we had 3,000 bushel of grain in a bin. This was barley, and it was in November, and I walked by it and I thought, oh, it almost smells like the line they put some apple peels around here. So anyways, no, they were not the apple peels that I smelled. It was the grain that was spoiling.
Yeah, my dad talks about 92 as, I think that was the year we had no summer. And yeah, I was alive in 92. But I was not fully involved in the farm yet, let's say. So yeah, definitely different years have different challenges as well.
Wonderful. Well, on behalf of everyone, James, thank you so much for being with us and facilitating this webinar for us. This is the first opportunity for us to partner with you, and we really appreciate all of the wonderful information that you gave us today. This will be recorded. Emily will send it out to everyone tomorrow so you can review it again. And thank you, everyone, for participating in this webinar, and we hope you have a great rest of the day. It looks kind of cloudy here in Markdale, but hopefully it's still pleasant. Take care, everyone.
Thank you.
Thanks very much, everyone.
Take care. Bye-bye.